what does it mean to be a perpendicular bisector? Okay, so it splits this into two equal parts and forms a right angle. Yep, because perpendicular means that we've got right angles there, and these two are going to be equal, right? So I can find y right off the bat by going what? 2y plus 2 equals 16, so 2y equals 14, and y is 7. Okay, so y, alright. So what do I also know, if that's a perpendicular bisector, what do I also know about these two parts? They're going to be congruent as well. So 7x plus 9 equals 11x minus 7. So now what? Minus your 7x, so I have 4x equals 16. So x is 4. So if x is 4 and I plug it in here, mn is going to be 37. And if I plug it in for lm, lm is going to be, if I plugged those in and didn't get the same answer for mn and lm, you know you did it wrong. Right? Alright. BD bisects ABC. That makes it a what kind of bisector? Angle bisector. Good, because it's bisecting an angle. So these two are, the angles are congruent. So 64 equals 5x minus 6. 5x equals 70. X is 14. Okay. What do I know about these guys? They're going to be congruent. So 3y minus 11 equals y plus 9. So y equals 20. Y is 10. If y is 10, what's AB? 19. What's CD? 19. Okay, so some properties there that we kind of had to review a little bit. All right, so your notes then are on page 10. So the first thing that we are talking about is called the circumcenter. Okay? The circumcenter is where the perpendicular bisectors intersect in the middle of the circle. Okay, so if you take all the perpendicular bisectors, so this guy, and this guy, and they intersect, they're going to intersect right in the middle there at what we call the circumcenter. Okay, so if we list the perpendicular bisectors, are going to be P is a perpendicular bisector. Okay, guys, what is a perpendicular bisector? Yeah, it makes a right angle and it bisects the side. So what part bisects the side? DE. That's the part that bisects it and makes right angles. DP does that side. So DP works. Okay, and what's the other one? Yeah, good. So far, so good. What is my circumcenter? P. All right, so we're going to start by listing some congruent segments. All right, we know that it bisects each side. So each side is going to get split into two congruent segments. So VE is going to be congruent to EC. What else? VD is congruent to BA, that's that side. And what's my third side? Yeah. AF is congruent to FC. Now, the circumcenter, what also happens is from the circumcenter to each vertex. So remember my vertex and my triangles are A, B, and C, right? So from my circumcenter to my vertex is always going to be equidistant. Right there. So from the vertices of the triangle. So the circumcenter is always equidistant from the vertices of the triangle. So I now have three lines that are also congruent. What else is congruent? BP is congruent to AP, and that is congruent to CP. Okay, from the circumcenter to the vertex of the triangle is equidistant on all three sides. So if we look at this, TU, which is this guy, can we figure out what TU is? Yes. Why? Because XU is 19, yep, and so these are going to be congruent, right? Because that's going to be 19 if that's 19. VY is going to be 17, because that's going to be 17. That's going to be 17. Because they're all bisectors. So they're going to be congruent to each other. UZ 21, yep, because you've got to go from the vertex to the circumcenter. So these are all going to be 21 and 21. But now what's WZ? You can figure it out. You can figure it out because we know that this is a right angle, right? So we have, well, we do know that because it's a circumcenter. We have perpendicular bisectors. So we know that that's a right angle because we have perpendicular bisectors. So if I have a right triangle, what can I use? The Adrian theorem. So for part D, we can go 15 squared plus x squared equals 21 squared. So 15 squared is 225. We'll tell you that next year for algebra 2, you're going to have to know your perfect squares up to 20. Now I'm going to study almost. Plus x squared equals. Those are requirements to have a calculator for this class, so you should have those all plugged into numbers. 441. Now what do I have to do? Subtract 225, so x squared is. Okay, square root of both sides. X is 14. So WV is 14.7. So what's TD then? So now we want the whole thing. So we got to double it and get 29.4. All right, so if we look at number 2, they want GB. Oh, no, GB is this guy right here. GD, yep, is going to be half of that 24. So that's 12. Because we have perpendicular bisectors. somebody's getting ahead of me. BC, oh, yep, 14, because we've got 7 and 7, gives us 14. EH, we could figure it out, yep, because we know this is 7, yep, and we know I heard that it was a right triangle, which you are correct. So now let's set it up. What do we got here? 7 squared, which is 49 plus x squared equals 169. X squared is 120. So x is 10.9. So 10.9 for EH. FD. How do you do that? Well, okay, so if I know pH, do I know HD? What's HD? 13. So now I have to do the big and there. Yeah, and this would come easier too if it's stay away. So part D, how do I set this up? 9 plus x squared equals 169. X squared equals 160. So FD is 4.6. So that makes CD 5.2. Okay, horrible?
Yes.
Well, we're also going to throw on incenters. Okay, so circumcenters dealt with perpendicular bisectors. Incenters deal with angle bisectors. All right, a little different this time. Instead of it being equidistant from the vertices, it's going to be equidistant from the sides. So now we're talking about PE, PD, and PF being congruent. Yep, from the incenter to the right angle, yep, is going to be what your stuff is congruent for. So you can say PD is congruent to PF is congruent to PE. Now, one thing that you have to remember with angle bisectors is that if this angle gets bisected, BE is also congruent to BE. Okay. AD is going to be congruent to AF, and FC is going to be congruent to EC. That's going to be important for your assignment, Gavin. It would really be helpful if you paid attention. Okay, so if I'm talking incenter, yep. Okay. So if we're talking incenter, NP, so this guy is going to be 8. So all three of these are 8. NK, you are, yep, because this is 17, this is going to be 17, yep. So then PK, what do I have to do? Solve it, yep. Pretty much, yep, every problem, well, and your assignment, yeah, I would say most of them do. So what do I have? 64 plus 17 squared. 289 equals PK squared. So I add those together, I get 353 equals PK squared. So PK is 18.8. And then it wants LO. So this guy right here. So what am I going to have to do? Yeah, I'm going to have to solve it again. So 8 squared, 64, plus x squared, 169, x squared equals 105. So LO is
10.2.
10.2. All right, last one. Do we know what GD is?
37. Okay, right.
GD is right here. We don't know. So what do we have to do? I get it. So help me out. X squared plus what's 35 squared?
1369.
Oh, I don't.
35
Oh, that's good.
equals, now we want 37 because that's my hypotenuse. 1369. So x squared is 144. Is that right? So GD is what? 12. That guy's 12. What's EG? 12. What's GF? 12. And to find everything else, you're going to have to use Pythagorean theorem. Except for FC. What's FC going to be? 35. What would GF be? 6. Good. And you have to use the Pythagorean theorem again for BG.